We're going to go into the next chapter now, which is the aircraft electrical power. All right. So there is AC on the aircraft, and there is DC on the aircraft, as you can see in this picture here. There are four AC sources through a generator, through an IDG on engine number one, through an IDG on engine number two, through the APU, and through an external power supply, if required, on the ground here. So on the ground, we invariably are using the external power or the APU generator. It's an either or. Both can't be supplying at the same time. If the APU generator is supplying, then the external power is not supplying. If the external power is supplying, then the APU generator is not supplying. So one of the two will supply the AC. Once the AC is supplied, you invariably power up the buses to AC bus 1, okay, and AC bus 2. These are the normal flows, and we have electrical power separation, obviously, because we want to keep the loads in an adequate arrangement, and we also duplicating stuff. Invariably, everything on the left-hand side gets supplied to AC bus 1, and everything for the right-hand side on the number 2 systems gets supplied by the AC bus 2. Now, I've produced AC, and I feed my AC to AC bus 1 will go to transformer rectifier number 1, and AC bus 2 will go to transformer rectifier number 2. What comes out of a transformer what goes in a transformer rectifier? AC goes in and DC comes out. Okay, so it's a very logical arrangement, very easy to remember. Generator 1 or the APU or external power to AC bus 1, to TR1, to DC bus 1, and external power generator, APU generator, whatever, to generator 2, to AC bus 2, to TR2, to DC bus 2 for the DC. Now, AC bus 1 automatically, in normal circumstances, if power was lost, will feed the AC essential bus. Okay. Similarly, DC bus 1, okay, will feed the DC essential bus in an emergency. And the last port of call is the DC battery bus, the 2 batteries, which will then come into play if we have no electrical power on the aircraft and provide 30 minutes of electrical power to enable us to land the aircraft wherever we can. There is enough logic circuitry in the system through what they call bus tie contactors, where anytime there is a fault on one component, another component will take over. Okay. So, for example, if in this case AC bus 1 was supposed to feed TR1 for DC1 to be available, well, in this case, AC bus 1 can't go to TR1 because it's faulty. So it will then, via the AC essential, feed to an essential transformer rectifier unit, which will then supply direct to the DC essential bus. Okay, so you can see there are these things called bus tie contactors, which automatically switch open, closed, all these different contactors to ensure that we always have 2 electrical power sources, AC and DC, on the aircraft at any given time. There is also an emergency configuration. Okay, so if I lost AC bus 1 and AC bus 2, then I would have none of all this and none of all this. In that case, an emergency generator, okay, will automatically supply directly the AC essential bus. Can't come from AC1 now because AC1's not working. So the emergency generator will supply the AC essential bus, and the AC essential bus will provide its essential transformer rectifier unit with some AC, and that will be converted to the DC essential. Okay. And of course, I will always have the two batteries. So we can see here a lot of different combinations of electrical power. So it's highly, 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 highly unlikely that an aircraft will have no power whatsoever. Okay, I don't know if you remember a 330 years and years ago, maybe 20 years ago now, landed in the Azores in the middle of nowhere in the Atlantic Ocean because it ran out of fuel. Because they basically had a massive fuel leak, and they did some switching and basically fed all their fuel into the side with the leaking wing, and they lost all the fuel. They had a flame out. If you have a flame out, then your engines don't turn, and if your engines don't turn, your IDGs don't work, and if your IDGs don't work to provide electricity, the aircraft becomes completely powerless, dark, black glider. Okay. Yes, I have a little piddly rat that comes out, but how much is that going to provide? And also, in terms of electrical power, how much is an electrical generator, emergency generator, going to supply? Not very much. I lose a lot of systems. So even with that scenario, okay, being over the Atlantic, they were lucky. The pilots knew the area as well, that they found they made a fix and said, okay, we can glide for 200 miles, and at 190 miles is this little island in the Azores. We're going to land there, and they made it. They made it. They had emergency extension of the landing gear, no braking, or not much braking, apart from the park brake, basically. Or what was that? The accumulator. And they damaged the aircraft pretty bad. It landed. It's just there was no wheels left. They were completely embedded in the tarmac. But if you don't have electrical power on the aircraft, it's very, 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 very difficult to progress for a prolonged period of time, especially over water. Okay. And at the last resort, this is what they had, basically battery only. Oh, no, this is even if the emergency generator's lost now. Okay. I still have the batteries, battery 1 and 2, feeding the essential battery bus, the essential bus, and also battery 1 feeding the static inverter, which the static inverter will then, it does the opposite of the transformer rectifier unit. An inverter will convert DC to AC. Okay, so in this configuration, then the static inverter will provide the AC essential bus with some power, so I can get some AC on the aircraft. Albeit in that configuration, the system will automatically load shed from all over the place, so that it will only keep the essential systems, so that we can land the aircraft safely. Okay, so you can see the various scenarios here. It's a very, very, very well thought out system. No switching involved. A lot of things happen automatically. To take the stress and the workload off the pilots. So if things happen, automatic switching happens, pilots get notified, but the load shedding happens, everything, all the screens don't get lost, they don't black out. And it's a very, very, very well thought out system designed 45 years ago.